Hello everyone. Myself Priyadarshini, working as assistant professor in the Triple Department of RMD Engineering College. Today we are going to see a topic from the subject Basic Electrical Electronics and Measurement Engineering. Okay. The topic is from the Unit 1 Electrical Circuit Analysis. Okay, so we will move on to the topic now. So our topic is today the theorems, network theorem. Okay. So, what theorem you are going to see today is Thevenin's theorem. Okay, so this is one of the important network theorem, Thevenin's theorem. So, what this Thevenin's theorem states? The theorem states that any two terminal, the main point is two terminal, linear network. The network should be a linear one. Okay. Having a number of voltage current sources. If it is having a number of voltage and current sources and resistance, it can be replaced by a simple equivalent circuit consisting of a single voltage source in series with the resistance, where the value of the voltage source is equal to a open circuit voltage across the two terminals of the network, and the resistance is equivalent to the that is equal to the equivalent resistance measured between the terminals, with all the energy sources are replaced by their internal resistance. Okay, right. So the Thevenin's theorem, what they are stating, that it can be said, it is applicable especially for a linear network. If I am having more than two sources, a number of voltage sources, it can be replaced by a single equivalent circuit or a simple equivalent circuit. The circuit should be consisting of a voltage source and an equivalent resistance. They are calculated or measured across the terminals, across the two terminals. Okay, so this voltage, it is also called as a Thevenin's voltage or the open circuit voltage across this terminal, two terminals, and this is the Thevenin's resistance. I can call it as a Thevenin's resistance or equivalent resistance that is measured across the terminal A and B. Okay, so this is one of the way to analyze the circuit easily, which is having a more voltage, that is a number of voltage sources and current sources or no. Okay, so next we'll see with the problem. Okay, find the current and voltage across what? The 24 ohms resistor using what theorem? Thevenin's theorem they have said. Okay, so the terminals are A and B. So we are going to find out the voltage as well as the current across the 24 ohms resistor, right? Okay, so here this is our network. So in this network, they have said it is a voltage source. I'm having a voltage source of 10 volt and resistance are 2 ohms resistor, 12 ohms and 24 ohms. So the current has to be found out across what? This 24 ohms resistor. So we are going to use the Thevenin's theorem. So this circuit can be converted to a Thevenin's circuit or Thevenin's equivalent circuit. So this is called as what? Thevenin's equivalent circuit. What are the three things should be present in the Thevenin's equivalent circuit? One is the Thevenin's voltage, another one is the Thevenin's resistance, another one is the corresponding load resistance, or across what we are going to find out are any value. Okay, so the three values: Thevenin's voltage, Thevenin's resistance, and this is our load resistance or load value, whatever may be. Okay, what is Thevenin's voltage? Open circuited voltage across the terminals. What is this? Thevenin's resistance or the equivalent resistance. Okay, so we have to find out this Thevenin's voltage and Thevenin's resistance. Right. So next is how to find out the Thevenin's voltage. What they have said, it is an open circuit voltage across the terminals what A and B. So what is the first step? We have to open circuit the terminals. So what is present already? 24 ohms has been present. So it is removed and this is open circuited. So across this we have to find out what is the voltage. Across this terminal, what is the voltage? It is present. So for that we have to use all other things or the parameters to find out the voltage across this terminals A and B. So we know in the parallel the voltage is going to be same. So if I found out the voltage drop across this 12 ohms, that is going to be what? The same, or it is equal to the voltage across this terminals A and B. Yes, so I have to find out the drop across the 12 ohms resistor. Okay, so how to find out the drop? The two ways I can use. One is normally Ohm's law by finding out the current flowing through the resistance, and then I can find out the voltage drop. Second is I'm going for what? Voltage rule, voltage division rule. Okay, so what the voltage division rule it says? Okay, so the VTH or open circuit voltage is equal to the voltage source. Okay. Voltage source is nothing but total voltage 10 volt into the same resistance. Also for across what we are going to find out. Okay, the same resistance plus the summation of the resistances. Okay, so you're having the two resistances, 2 ohms and this 12 ohms, and both are connected in series only. Why it is connected in series? Already I told you. Since these two terminals, so like this only the current is going to get divided. So here it is open circuited, so definitely the current is going to be zero. The same current is flowing between 2 ohms and 12 ohms. So we know if the same current has been flowing between 2 ohms and 12 ohms means both are connected in what? Series. Okay. So how to find out the voltage across this 12 ohms resistor? Total voltage, right, into the resistance for which we are going to find out plus the summation of the two resistances. Okay. So summation is nothing but 2 plus 12, 14. So total voltage into that corresponding resistance 12 by 14. Answer is 8.57 volt. So what is our VTH? 8.57. What is our next work? I have to find out the RTH. So how to find out the RTH? To find out the RTH, I have to find this equivalent resistance across this. Right? So how to find out the equivalent resistance across this? So 2 ohms and 12 ohms, and this has to be what? Short circuited, because since it is a voltage source it has to be short circuited. Suppose if it is the current source it has to be open circuited. Okay, so RTH, R equivalent. Okay, so R equivalent from this, right, we have to look it up. If I'm seeing in this direction both are connected in what? Parallel. Okay, so both are connected in parallel means 12 into 2, that is R equivalent is R1 into R2 by R1 plus R2. So 12 into 2 by 12 plus 2 is 1.71 amps. Okay, so 1.71 ohms. So this is my R equivalent. So this is my VTH and this is my RTH. The next is, okay, the same, this circuit has been replaced. See here, Thevenin's voltage, Thevenin's resistance, and that load resistance. So these two resistance are connected in series. So what we have to do? V by R. So V is 8.57 volt divided by 1.71 plus 24. The answer is 0.33 amps. So the current flowing across this 24 ohms resistor is 0.33 amps. Then what is the voltage drop? Voltage is nothing but V is equal to what? I into R. So 0.33 into 24, that is going to be 7.92 volt. So the voltage across the 24 ohms and this is the current across the 24 ohms. So we got these two things. So this network has been reduced by Thevenin's by using the Thevenin's theorem. So what is the use of a Thevenin's theorem is, even though it is a big circuit, if I am having more than two sources or many sources are there, it can be simplified into a simple equivalent circuit, Thevenin's equivalent circuit, and from that I can able to find out the load current. The next theorem we are going to see is the Norton's theorem. Okay. So what is the Norton's theorem? It's saying, right. The Norton's theorem states that, so it also is saying it is a two-terminal, two-terminal linear network or with the current sources and voltage sources are present. It can be replaced by an equivalent circuit. Okay. consisting of what? There it is voltage source, here it is what? Current source in parallel with the resistance. Okay, in parallel with the resistance. Okay, so what is the difference between a Thevenin's theorem and a Norton's theorem is, in the Thevenin's theorem, the same thing we are replacing by an equivalent voltage source. But here we are replacing by an equivalent current source, but the resistance should be in parallel. There the resistance should be in series. How to find out this current source? Okay, how to find out this current value? Correct. So the current value, the value of the current has to be found out. How to found out means, correct. If any values, so the load resistance has been mentioning means what? We have to short circuit that. Okay. And after short circuiting, we have to find out what is the current flowing between the two terminals. Okay, the resistance is already we know it is an equivalent resistance. Right. So the same thing, the Thevenins and Nortons. But the difference, what is the only difference is, there the equivalent circuit consists of an equivalent voltage source and equivalent resistance, which is in series. But here, equivalent current source and the resistance is in parallel with this. Okay, so this is called as what? Norton's equivalent circuit. Okay, Norton's current or equivalent current. This is the resistance parallel with that. Okay, so this is problem. Okay. So find out the current and the voltage across what resistor? So across the 6 ohms resistor using what theorem? Norton's theorem. Okay. So we have to find out the voltage and the current across this 6 ohms resistor by using what theorem? Norton's theorem. So the question has been given, mentioned here. Right. So the same thing, the 24 voltage source is here and two resistance I am having. One is 5 ohms, another one is 10 ohms, another here is 6 ohms resistor. So what we have to find out? First we have to find out the equivalent current or Norton's current I have to find out. The next is I should find out the resistance, equivalent resistance. Right. So how to get these values? We will see. So they have given, so we will find out how to get these values. And then I will draw the diagram. How to draw the diagram? The first is we have to short circuit the terminals A and B. Okay, short circuited the terminals A and B. Okay. After short circuiting the terminals, we have to find out what is the current flowing through the short circuited terminal. Right? So I have removed that resistance. So what is my load resistance? 6 ohms. I have removed that resistance. Then I have short circuited the terminal. So then I should find out the current. Okay. So how to find out the current? So here what they are saying is, so this is my voltage and this is my resistance which is connected in series with that. So what is I? I is equal to V by R. V is 20, R is 5. So 20 divided by 5 is 4 amps. Then everyone will be having a question. What will happen to this 10 ohms resistor? Yes, you are having the question, right? The 20 divided by 5 is going to be 4 amps. The 4 amps is flowing like this. Okay, then it is going to come here. Then it has to be divided. So like this, it has to divide. Just you have a look. Here the resistance is how much? 10 ohms. But here there is no resistance. Resistance is going to be 0. So usually which path will be selected? Okay, right? Since there is no resistance, so since there is no opposition to the flow of current, automatically this current will be selecting this path alone, not this path. Okay, since there is no opposition, the total current will be flowing through this, not through this 10 ohms resistor. So the current flowing through this short circuited path is 4 amps. Okay, right? Okay, so we got this Norton's current, and next is equivalent resistance. So how to find out the equivalent resistance? We have to open circuit the terminals, that load resistance. After open circuiting this, consider these two things are connected in parallel. So R1 into R2 by R1 plus R2. So 10 into 15 by 10 plus 15. So 50 divided by 15 is 3.33 ohms. So what is our answer? Answer is it has been converted 4 amps equivalent current, and that is connected in series is 3.3 ohms, and here the load resistance has been connected. So the same thing, we can use the current division rule, total current into opposite resistance by summation of the other two resistance. So answer is 1.43 amps. Since if I want to find out the voltage across that, so after finding out the current, you multiply with the resistance, that will be giving you the voltage across the 6 ohms resistor. Okay, so these two theorems will help us to solve a complicated circuit or a complex circuit in a simple manner. So both the things are going to be what we can say is of a vice versa. Here it's a voltage source, there it's going to be a current source. Here the resistance is connected in series, there the resistance is going to be connected in parallel. So okay, right. So there here they have given find the equivalent circuit for the circuit shown. Okay, Thevenin's equivalent circuit for the circuit shown. So for this, we have to find out the Thevenin's equivalent circuit. So these two are the terminals. We have to find out the VTH and RTH. So here we are having two sources. One is of a 50 volt in series with a 10 ohms, another is of a 10 volt in series with a 6 ohms. Thevenin's equivalent voltage is the voltage across the terminal A and B. Okay, now what they are doing? The voltage across the A and B is the voltage across, right? That is V3, the 3 ohms resistor, and the voltage across the 6 ohms resistor plus the 10 volt, the overall path. This path alone we are taking. Okay. So here the current passing through this 3 ohms resistor is zero because it is of an open circuit. So by applying this Kirchhoff law, right? If I am applying the Kirchhoff law here, voltage rise is equal to what? Voltage drop. What are the two voltages rises here? One is of 50 volt, another is of a 10 volt. So if I apply the current action, so this is going to be a positive because this will be moving from negative towards a positive. And if I am considering for the second source, it will be moving from positive towards the negative. So this is going to be a positive 50 volt, and this is going to be a negative 10 volt. So 50 minus 10 is going to be a 40 volt. Then what are the other things? This I into R. If the current is going to be I means I into R. 10I plus 6I. So totally 16I. So 40 divided by 16 is going to be 2.5 amps. The current flowing through this loop, this path is 2.5 amps. So from that, the 2.5 amps, I can able to find out the drop across this. Okay, if I multiply with the 6 ohms, so 6 into 2.5, I will be obtaining that's going to be 15 volt. So 15 volt plus 10 volt is going to be what? 25 volt. So the voltage drop across this A and B is 25 volt. So what is the Thevenin's voltage? 25 volt. Yes, these are the other ways. That is, if I am having more than two sources, I can able to find out by using this method. Okay. So thank you everyone.